into it, and we're sort of leaning more and more towards this in modern sciences, phylogeny, by really saying that, well, all members of a species have to have a common ancestor, and so we can look at their DNA and find out if that actually is the case. And the lineage actually has to be continuous for that to be true. This is most useful for establishing relationships between different species. You can compare one species to another by the DNA, by the molecular evidence, and see how closely related they are to each other. Of course, there's a problem with this too, is all extant species, all species that are living now, all have a common ancestor. So where do you draw the line? It's kind of tricky. And this is an example of cladistic organization of some species, and this is how these phylogenies are derived and what they're useful. Now, there's a further problem, which I find incredibly interesting. And you can actually find a little bit more of this in detail in Richard Dawkins' book, The Ancestor's Tale, in the section called the Salamander's Tale. It talks about ring species. And ring species are a very interesting phenomenon that really show the mechanism of speciation and sort of blur the lines of how we actually categorize species. Let's say I've got a line there. It's 5 different colors: red, orange, yellow, green, blue. And if you look at any two of those right next to each other, they're pretty close. They're related. The red and the orange, you can see those being the same. The orange and so forth. And so imagine that there is a species or a population of organisms that have a similar progression, where the species on the far side is distinct, and then the next one is a little bit different but close enough, and then the next one's a little bit different but close enough, all the way down. Well, let's say that instead of being spread out on a line, let's say they're circled around something, like some geographical structure, let's say, and they come around. Well, you can see that the blue is just about to overlap with the red. And in fact, when that happens, you can get those species which are in a common progression from one point to the next. All of a sudden, the tail is back to the head. And it's quite possible that the differences that have accrued as these species have spread out along this line are significant enough that the first species and the last species cannot actually interbreed. And we call this a ring species. And there are several examples, and I'll give you a few of them now. The first one of the classic examples, is the Herring Gull, Larus argentatus. It's basically, a seagull. And there's a model proposed by Ernst Mayr that the seagulls had actually arisen like near the Baltic Sea and gone north, where they hit the Arctic Circle, and they spread around the Arctic Circle in both directions. And here's the representation of the Earth looking down at the North Pole, and you can see that the Arctic Circle is basically, around this way. And it starts off with Haugland's gull here, and the progression would have been in both directions, and you ended up with the lesser blackback gull over here in the Norwegian peninsula. And the progression goes along the other way, along Siberia, into Alaska, and across North America. And you see these different species that exist today. And there's a progression on both directions, and they end up back here in England, where you have the herring gull and the lesser blackback gull are really close enough that they share the same territory, but they do not interbreed. And so what you have is you can hybridize blackback gulls between the Siberian lesser and the lesser. You can hybridize anything in between, except when you get to the end, and the herring gull and the blackback gull cannot interbreed. So we consider that a ring species. There has been some research recently, actually, out of Germany and the Netherlands to suggest they looked at actually the genetic evidence, and they were saying that the herring gull and the American herring gull are actually not distinct enough genetically, and so they don't really classify it as a ring species yet, because the head and the tail have not met, although they did admit that the blackback gull is migrating over into North America. So within the next 5 years, it is going to be anyway. And so I'm just going to show you some examples of these so you can actually see what they look like. And this is the blackback gull. You can see the mantle. The feathers on its back are very, very dark. And I'm going to progress through all the way around it and watch those feathers and see how light they get. And then finally we're here at the Herring Gull back in England. And you can see that the feathers here really are light silvery color. In addition, they actually get bigger as you go around the Arctic Circle. And here's all of them on the same slide. You can see that progression. And this is actually a herring gull and a blackback gull standing right next to each other. So they are very, very different, just sort of morphologically. And almost every criterion that we have for a different species, they are different. They don't interbreed, they look different, they do different things. But if you go around the circle, you find hybridization all the way around. So it's kind of a problem. There's another really good example, the Green Warbler, which is found in central and northern Eurasia, Phylogeny trocholoides. The ancestral species was in the northern regions of Nepal, and it's still there. There's still a species there, and it expanded northwest and northeast around the Himalayan plateau. And this is a picture of the Himalayan plateau. You see India down there at the bottom, and all these mountains. That's the Himalayas. And what happened was you have the greenish warbler that started off in Nepal, and it sort of migrated both directions because it couldn't actually go into the mountains, so it just went around. And as it did that, speciation occurred, and you get the dull green warbler over in the east, the bright green warbler in the west, and then the green and the two-barred up in central Russia. And this is actually, this shows the progression of these species. This is the original, the green warbler, greenish warbler. And this goes around the east side, and then that's the west side. And you can see them all. You see that progression. There's not that much morphological change among these species. It's kind of interesting, the way they've been able to determine that they are actually different species and they don't interbreed is because their song is different. Each species is sort of defined by its song, and that's how they attract mates. So if you have a different song, you can't attract, this bird can't attract a bird from that as a mate because it has a different song. So that's kind of interesting. And finally, the Monterey